My name is Steve Karlin. I'm with Pervious. What I've done today, and it's interesting listening to you guys. I've worked with cities and municipalities and airports for a long, long time. And it always amazes me the amount of different subjects you guys get involved with and everything you do. And I feel like the only guy in my neighborhood sometimes that appreciates it. So just want to throw that out there. So a lot of my pictures today are coming, it's kind of a review of what we see with this cleaning equipment. I got some photos and examples. I'm trying to lead the discussion about Pervious and maintenance of it. I've got a study by NAVSEA, which is a military organization. It's a research group from the US Navy. And the reason I have that is our technology, this high pressure wash surface cleaning technology. We actually developed that in conjunction with the US Navy to clean aircraft carrier decks. The aircraft carrier decks obviously are not pervious, but they are terribly polluted. And the similarity there between that and roads is, regardless of it's pervious or impervious for you, there's lots of debris and lots of chemicals and metals, as Ani mentioned, on your road surfaces, and that becomes part of the cleaning solution anyway, whether you're doing pervious or impervious. We've written a pervious maintenance guide. That's where basically we're gonna end up today, is one particular page on that, in that pervious maintenance guide. And then I'll probably be referring from time to time to a study by the University of New Hampshire Stormwater Center. We did a demonstration out there. Their program for years, they're pretty much like the Washington State University Stormwater Center, but every time the material or the installation procedures for Pervious made a major change, they installed a Pervious facility on their campus. And so they've got 5. First one was in 2004 and the last one was in 2012. And we did demonstrations cleaning on all of them. And I'm not going to bring up that study today, except for a couple of things that they mentioned in it. But all of this material is available on our website. At the end of the day, you can go there. The studies, are several other studies, and our maintenance guide is there for download and so on and so forth. So I said we want to talk about Pervious in the Pacific Northwest. So the first place we're going to go is Rego Park in Queens, New York. And if that doesn't make sense to you, I guess that's the intention. We did a demo out there. They had a test installation in Rego Park in the Queens. And you see what they did. I'm assuming you can see my cursor, is they put in curb blocks of precast concrete Pervious on both sides. The roads are crowned, so they are draining their roadway into this Pervious. And they put it in one particular section of their stormwater sewer grid. And they measured the outflow of that before they put it in and the first season it was in, and they reduced their stormwater that flows from rainstorms, that flows into Long Island Sound out there. They reduced it by 60%. So they were very, very happy with that. It was installed in the late spring of 2018. And they asked us to come do a demonstration in the late summer and fall of 2019 because it was already clogged. And on the right, you can see why it's clogged. Now these leaves aren't clogging that Pervious, but of course those leaves, this is the fall, what it looks like in the fall. It's a very dense, a lot of forested areas there in Queens, a lot of trees, deciduous trees. The streets are littered in the fall with the leaves. Of course, the traffic pulverizes them. The other heavy loading period for biomass and nutrients and all this other stuff is in the spring, when the buds come out and the cases fall off and the streets are full of the biological material again. And again, they get crushed. And every time it rains, of course, the the small sediment flows to the gutter, which is the point, and the water goes down through the pervious, and then this material just gradually fills it up. And this is, so there's two, and your area is going to be pretty much the same. You've got a few differences, but in the spring and the fall are the times when your streets are full of tree material and matter and so on. And in this case, when it gets pulverized, gravity is not your friend, because all those small particles are going to end up in your pervious, and some of it's going to stay while some of it flows through. So we did a demo, and this is a very short little video of that demo. It's got subtitles and there's no sound to it. So this one we're able to show, okay, it's just about a minute long, and there's legends underneath. So the lesson we learned out in Rego Park, or everyone learns, of course, is keep the litter off your streets. And everyone's got their own schedule of street sweeping. I just heard monthly a minute ago, and that's a very good thing. Regardless of the fact that you're cleaning it up monthly, unless you're out there every single day, of course, there's going to be material on the streets. It's going to get squashed, and that's not a good thing for your pervious in the long run. There's also wear and tear from tires. There's the dust in the air and so on and so forth. So your streets, as you know, are always covered with different material. So that strategy of draining a street, impermeable street to pervious gutters, or is the same as you use a lot of times in the Northwest. This happens to be a street in Tacoma. And in this case, it's not curb lining, it's the parking lane. And there's probably an engineering reason why it rains so much. When it rains so much in Tacoma, you need a parking lane to drain that material, that water off, as opposed to Queens, where a 5-foot slab is good enough. But that's the same idea. And we're back, as several times it's been mentioned, of how much area your permeable surface can drain. U.S. Geological Service in Minneapolis, Minnesota, actually was doing some studies in a parking lot in Minnesota where their ratio was 10-1. And they thought they could drain an entire parking lot by having 10% of it pervious. About 3 years after they started doing that, they were down to 5-1. And they were just finishing that, and they're moving to 3-1. So there's a lot of information on that, of course, and a lot of study going on there because of the cost of installing this stuff and because of some maintenance issues that it has. I think I saw the number today with I think it was Ani's presentation of 2-1 or 1.5-1, being a little more conservative than the people in the Midwest were. This is Poulsbo, Washington. They have the same strategy. They have some parking lanes that are pervious. And we went up to do a demonstration there. And in this particular case, it was kind of interesting. It was raining that day, very lightly, but it was raining. And we were on top of a hill, and I can't tell you what hill we were on. But behind the camera here, it goes down fairly steeply down to an intersection. And this material, this is all the pervious in this area. The water was coming down this roadway and across until it hit an uneven portion of the road, and then down the road it went. And it happened to be the lower point was in almost like a tire tracks down right in this area of the parking spaces. And you can see these two pictures were taken about a pass or two, test pass. This is non-treated, so this is on Pervious, and the water's flowing across all the way down and ending up in the intersection down below. And after we'd made a couple passes, you could see it was disappearing here into this, into that Pervious, only a few feet into that parking spot. And as the people that are here today from Paulsbo know, all of these sidewalks are also Pervious, and we went up and did some cleaning on there too. Here's a cut. This is really a unique issue that I've seen in the Pacific Northwest, and that's moss. That left-hand picture there is Paulsbo down on another street, and you can see just, you know, depending on what's next to it, this tremendous moss load here. It's slick, it's dangerous. Nothing's gonna permeate through there. Nothing's gonna percolate. You can see where we did a little test patch here, and then we were gonna come down and clean this up for them. This is an interesting picture on the right. It's a Pervious sidewalk in Salem, Oregon. And again, back to what some of these other guys were talking about, is the flow from neighboring areas onto the Pervious is not your friend. This is a fairly, not a real steep slope here, but it was undeveloped and it was just kind of open. There were some bushes and trees planted there, some wildflowers and so on, but it's kind of open ground. And kind of, we see this a lot actually. This, I think, the guys that were there with us there in Salem, Oregon that day were not aware of when this was put in. It was put in before they came. So it was at least 2010, and it had never been cleaned. And interestingly enough, you can see it's very heavy to mold or moss right along the edge, and then it kind of thins out. We made 3 passes on this, and the first pass took the moss off and showed us exposed like 3/8 to a 1/2 inch of mud that was laying on this sidewalk under the moss. And of course that mud got shallower as it went over, so there wasn't nearly as much out here on the edge. So the next pass we took the mud off, and then the next pass we were able to get down to the Pervious. So this is one of those cases of really a pollution of your surface from the neighboring, and they've never been able to do it. They've never done anything really to modify that. We were out there in December, January, I forget, December, I guess. And by next year, it'll be somewhat the same, because every time it rains, that dirt is going to flow down onto that sidewalk. So we talked a minute ago, I heard we're all talking about how often you test, how do you do it? There's lots of ways. This is the one that was mentioned. I think Mr. Siegel said it. The official test, you put the cylinder down, you put a very low, small head of rainwater in that cylinder, and you determine how much water can go through, percolates through in the gallons per minute, gallons per hour. That's one way to do it. Another way is to turn a hose on it. This is an interesting, in 2004, a company called Kurt Concrete wanted to sell Pervious concrete. So they laid on the left here is gray Pervious concrete. They put it in 2004, and we were just talking about bioload and tree cover. This is in quite an open area. This is not a forested area that this is here. And interestingly enough, pretty much as far as we've seen, right on schedule, it was clogged and non-functional because in 2 years. So in 2006, they gave up trying to sell Pervious from this place, this block. So this rose colored, they put this in, and it was they put that in 2007, and right on schedule in 2009, 2010, it stopped working also. So how do they prove to us it's not working? those are concrete, those are concrete people. They're not public servants. So they don't have that fancy test. So they run a hose on it, and the hose, everything just ran right off and through. So easy enough to do that. You turn a hose on it. Is the water going through or not? Paulsbo actually taught us a pretty interesting trick where you meter the amount of water to go on while you're testing. And they showed us, this is what they were doing. They had the 16-ounce bottle of water. You turn it over and pour it out onto the concrete, and you watch how fast it goes. And you can time it. It's a very short thing. And we were doing that up at Paulsbo between passes, and you could see the improvement of the percolation by pass with a very simple, cheap, easy way to do it. Not by the book, however. But you can go out and look. And this, we also heard people driving around taking a look. This is obviously not functioning. It's a pavers. You can see there it's not raining at that particular time, but it's obvious. If you're there within a half hour to 45 minutes after a rainstorm, you can see that that's not functioning. You got to do something about it. But as this is Olympia, Washington, doing the simplest and cheapest, the cheapest and most effective tool that I've been told for judging whether your pervious pavements are functioning properly. The cheapest and most effective tool is an umbrella. If you go out and it's raining, you can see firsthand whether it's draining or not. This happened to be a school parking lot in Olympia, and it's pervious, believe it or else. And this is obviously not working. This is actually after we did a little demonstration, which you can see this dry spot here. We went up and cleaned that little area between the cars, and the water, we picked up the water that was there first. And then of course, as it continued to rain, then it was percolating. Okay. So you all know, you're familiar with Pervious. That was an interesting question that Angela had in my mind. It was very interesting about milling pervious surfaces. The owner of Triveris actually was at Washington State University many, many years ago, where he learned that the pervious, for various reasons, I'm sure it's an engineering thing, really clogs in the top 3/8 of an inch to a half an inch. And that's where the small debris and the solids and everything else worms its way down through the voids and piles up without going any further. So the clogging that we're all dealing with is really in the top 3/8 to half of an inch. And it was interesting to me, and this is just my reaction, when Angela says, what about milling it? She hit the number. When you're going to mill it, you're going to take what, a 1/4 inch off or something like that. So you're going to take most of the clog away from pervious with that milling. And of course, it doesn't last, because now you got the next 3/8 of an inch to a half inch will clog over time, but it would be effective for one time. One thing you can notice when we're trying to see if material is clogged or not, this is to me just an interesting observation. This is pretty rough material, and we had a couple guys mention the roughness of pervious. This is where we stopped with our cleaning, our high pressure wash, and this is the pattern that's left by the this is the pattern that's left by our spray. So this is clogged, and you can see it's a flat table. There's material on top of that pervious material. It's not just inside, it's on top, and that's got a lot of pollutants, and it's everything else that's been packaged there that's never gone down through that medium, that pervious medium. But when you clean it with a pressure washer, the topography comes back. So I was interested in a lot of Paul's pictures, looking, and if you go back and look at that, if you get Paul's presentation, when he's showing those pavements and those sidewalks, it's very, very obvious that texture on top. Those in particular, he showed a new one, and it's just beautifully rough there because it's clean. And this is your average run-of-the-mill guy is going to walk past this and it looks fine because there's no leaves and debris and pine needles on it. But underneath that, there's more problem. And of course, this is clogged, absolutely. I'm not a real fan. You know, I know they look really great, but I'm not a real fan of pavers because the surface area through which you're passing your rainwater is quite limited in this section compared to this. And the other thing I really don't like about it, I don't know that there's any machine that does any different. High pressure washing can get this out of there. We can do it. A lot of people can do it. But the aggregate comes out too that keeps those bricks in place. And it's a mess. There's an extra step to it. Some people throw the aggregate away and put in new. Some people wash it, put it back. It's that one extra step. It looks really, really nice, but to me, that's one of the drawbacks of it. So we were just looking at the surface, the material on the surface of that pervious. And now this is, I'm talking about in not only in the material that's down in your pervious, but what's laying on top. And why Paulsbo definitely, and just think back to that last picture of Paulsbo with the sheen of particulate and solids blanketing the top of that pervious. Paulsbo sweeps. And why is that still there when Paulsbo sweeps? And this has to do with the nature of sweeping and the amount of energy that's applied to whatever happens to be on that roadway. So if you think about a street sweeper, the primary application of energy to that surface is a flexible broom, whether it's a steel gutter broom from a street sweeper or whether it's a plastic, a poly broom. The broom is glancing off. It's at an angle to the material that's stuck to that's on the pavement. Anything that's loose is going to come up. That's enough energy to raise the dust, to raise any material that's laying loose, the cigarette butts and everything else. And then, of course, we spray water on it to keep the dust down. But the only thing that's coming up really to a huge extent is the loose material. Whereas with any kind of, to get that sheen and that blanket of material off of that pervious and then get down in the pervious, you need a lot more energy than that. So this is the chart I was talking about from NAVC. This happens to be on non-pervious material and it's in an industrial area. So these numbers of these zinc, titanium, lead, iron, copper, barium, aluminum, and all that, those are going to be pretty high in this area because of where this test took place. But what they did is they said, let's look at 3 different ways of cleaning the pavement. Let's use a broom. And they used a broom. They set off test plots that were equal to each other. And they said, let's use a broom. And that's a mechanical sweeper. The only thing that's not there is the vacuum, but the dust broom and those bristles is going to move what's loose. And that's what we're doing when we call for a dust broom. And the next way we were going to do it is a wet vacuum. And what they did for that is they flooded the area and then they vacuumed it up. And I'm sorry, I don't know how long they left the water sit, but they flooded the area and then they vacuumed up to see what the water would break loose. And then when we get to McChris, that's some US Navy acronym. It's actually our technology in the MCV. What we collected is down here. So just to show you this chart a little bit more, before and after, what that was the first pass, they got a certain amount of material up off of the test patch. And they said, okay, how do we know we got all of it? How much do you think we got? So after the first pass, they went and did it again in exactly the same spot. And they saw that the numbers went down so low, they said, okay, we are as effective as we're going to get in that first pass. So that's what the before and after is. So what we're going to look at here in numbers that make sense, these numbers are all in micrograms per liter or something like that. And then they calculated back up to pounds per acre. This is non-pervious. This is just a hard surface. And remember, that material that we saw creating that sheen on the pulse bow pavement, that's adhered to the surface. There's a bond there, a physical bond that's holding that to the surface. So the dust broom, we go by with the street sweeper, and total suspended solids, when they did their testing, they got 8 pounds of solids, of suspended solids. Now, if you take the coarse stuff that came up the first time and did not stay in the water when they sat and they floated it, you get 16 pounds. So the total number of pounds of dirt and debris they got off with a street sweeper was 16 pounds. The wet vacuum, as we're talking about the wet vacuum, in the same pounds per acre, the wet vacuum, which we soaked loose from the pavement, they got a total of 41 pounds of total solids and 54 of suspended solids. Now, the other technology, now that what this is what Paul mentioned. How do you clean your sidewalks, Paul? You high pressure spray them. And that's what our machine does. High pressure sprays. We were getting over 400 pounds of dirt off of the same material, the same test area, similar test area. If you go back down here to the pollutants, here's another good one, aluminum, barium, copper, iron, lead, titanium, and zinc. You can see the zinc, our technology picked up 44 times what the street sweeper did and about double what the wet vacuum did. And what we're doing, we're picking it up with that spray wand that Paul is using out on the street, and we're containing it. We're lifting it up and containing it. Recently in the news this is because my mind floats from one subject to another. There was a study done, and I believe Washington State University participated in that. What is killing the coho salmon? And they isolated a preservative in tires that every tire has. And while the tires wear out on the street surface, it's deposited on the street surfaces. And then when you come by with a rainstorm, which is basically the wet vacuum, right? You're going to soak it, and then you're going to, whatever you can get loose is going to go with the stormwater. This chemical is going into the streams and evidently killing the salmon, and that's called 6-PPD. And I've been calling out to several people on the coast. We'd like to see what our technology could do to pick up the 6-PPD that's on the streets out there right now and keep it out of the storm drains, keep it out of these salmon streams. And the key item there would be not in comparison to someone else, but how much is left, how much of we would pick up and how much would be left. And that's kind of something I've been thinking about since I read that study. So how do you clean? If you're going to try to pressure wash, that's how you get energy to a surface. And Paul said that's how they do their sidewalks. The Vector can't get on the sidewalks, but it can certainly go over there and suck up what you pull up. Very effective, not really efficient as far as time goes. And at the University of New Hampshire Stormwater Center, we were talking to the executive director there, Jamie Houle, and he was telling us that they did a study on their own Pervious, one of their Pervious areas, and they got excellent recovery of clogged Pervious, and all of their material has been clogged 2 to 3 years after installation. They're clogged, and regardless of when they sweep or how often they sweep, because of this small stuff that gets down inside the Pervious that the street sweeper can't reach. They cleaned a section, and they got great recovery of their percolation rates. But it took 2 men 125 hours each to do an acre. And it just, Ani has mentioned, not only is the installation of Pervious material expensive, so is the maintenance. It just goes with the territory. And that's pretty outrageous. There, no one has manpower to go out and hand wash. Let's say Paul sends his guys out to do his 400,000 square feet of Pervious. He better start hiring new people because they're not coming back till Christmas time. So what we've done is we've used that hand spray technology, 3,500 PSI, and we've captured it inside our front deck. So all we're doing is that effective application of energy to the surface in a 5-foot path. And this is bird poop, happens to be just bird poop in a on a dot. I don't know if you can hear that or not. So this is how you change that topography. And topography is one thing because that's what's showing on the surface, but how does it get down inside the voids? Those underneath, you can see on the right hand here, you can see we have spinner bars with spray nozzles. And if you're sitting still, that's the pattern they make. And as you move forward slowly, and you remove all of this material off the top. But it's also a very fine stream, so it actually penetrates below the surface through the void and dissipates its energy as it strikes anything and changes direction. And it'll do that down through that top 3/8 of an inch. By the time it gets to the bottom of the 3/8, there's nothing left. But where does that energy go? It excites the material that's adhered inside those spots or even loose inside that. That energy enters that material and it moves it. And which direction can it move? The easiest way is up. So it comes up off the surface and we're going to pick it up with a vacuum. And that's the technology, which is Paul's Vactor, along with his street strape, his maintenance workers with their spray wands. We're doing it underneath that deck. So here's again, topography change. And it's interesting to me, if you look on the left, this is Amtrak in Seattle. Great topography here. Here's that same ugly, dirty, black looking that you walk across and you never see it because it builds up gradually and it all looks the same. But here's the difference when you put that energy into that material. This is concrete. I think this was Federal Way concrete, and you can see there the voids are down here and it was filling up with the moss. And once you get rid of the moss, you got to get rid of the food source and the base that it's growing in. And that's what we're doing down below the surface with that spray wand under their 3,500 PSI. So talking about inspections, this is a curiosity to me. It means nothing against whoever did this or not, but it's an interesting thing. We did a service contract and we asked where are the areas, and you should measure them before so you can see if we were effective after. And so this is a little excerpt from the spreadsheet they gave us. And here's 3 different patches and the notes from the guy, the professional guy that's out looking. Well, it looks pretty good. Yeah, it looks pretty good. Yeah, it looks pretty good. 3 times, which it does. It looks great. You walk across it all the time. And here's the column in his table, failed infiltration test. Yes, yes, yes. So it looked great. What's that saying? Looks great, tastes terrible, or tastes terrible, looks great, or whatever that is. There's an example. Now it's interesting. Here's some more from the same area, and 3 times in these, and these were just in the chart. There was like 10 or 12 of them. Some areas heavy soil, some areas heavy soil, some areas heavy soil, and failed infiltration test. Yes, yes, yes. So what that is just like I heard just a minute ago in the presentations, You guys spend $6 a square foot to put down pervious. The homeowner comes in and the gardener comes in and he dumps his dump truck of mulch and dirt out on the roadway, right on your pervious. It's not a week old. And that's going to leave a stain. It's going to leave an area. So those areas are very visible, and you can see them in oil patches. You can see them in grease and things on the street and so on. That shows up. But when that surface is homogeneous looking out, it just does not show up like you would think it would. So I got a video, and this is actually a video in the Pacific Northwest. And it's on a street that it's on a street that's swept all the time. You know, I don't know the frequency of street sweeping, but this is an area that's swept all the time. Very presentable area, nice town in Puget Sound. And if you'll just take a notice of what came off of and out of that surface that has been swept continually ever since. And these happen to be the areas that just failed the percolation test. So I'm going to stop sharing because this video is narrated and I couldn't get the sound to come up. So Lori, are you there?
Yes, I am.
Okay, I'm going to stop sharing. So okay. Lori is going to put the video on. We're going right to YouTube for this video. Rates in pervious that has become non-functional due to accumulation of both organic and inorganic material within the voids of the pavement. This demonstration shows the cleaning and recovery of pervious surfaces in the Pacific Northwest. A casual glance at the surface does not reveal the actual plugged condition of the surface. The Pervious system is mounted on a multi-purpose toolcat carrier to allow additional applications when the cleaning system is not required. The 60-inch wide cleaning platform provides excellent productivity. The high-pressure water spray is contained under the cleaning platform by an adjustable, flexible membrane and brush. The space between the brush and the pavement also serves to meter the high-volume, low-velocity airflow into the contained spray area. Under the platform, the water and dislocated solids form a slurry. The metered airflow captures the slurry, which is transported up the recovery hose to the recovery tank for collection and disposal. Because of the high amount of mechanical energy the MCV process delivers to the pavement surface, it can also lift and contain adhered solids and heavy metals, as well as oil and gas residue that are beyond the job description for conventional mechanical, regenerative air, and vacuum sweepers. The MCV is also designed for operation within covered parking structures. The MCV recovery module includes fill ports on both sides to always allow refill of the 200-gallon clean water tank from the curbside from either a hydrant or support vehicle. The recovered dirty water is offloaded by means of a low-pressure pump. The clean water tank is typically refilled at the same time the recovered slurry is being offloaded. The slurry, loaded with contaminants recovered from the pavement, drops into the recovery tank through an air-water separator. It then passes through a dewatering gross solid separator. In true operational conditions, this is dumped into a waste container carried on a 1-ton or other support vehicle, while the solids-laden slurry is pumped off the MCV under low pressure. In this case, a vector is used for the clean water supply, the recovery unit for the solids-laden slurry, and the accumulated solids. Your operation may differ based on local equipment and conditions. This Puget Sound area demonstration showcases recovery of fully clogged pervious, where percolation rates were approaching zero. In this case, the solids recovered from the pervious surface in just one pass are overwhelming. On surfaces that are on a scheduled seasonal maintenance program, the onboard recovery tank rinse system uses water from the clean water tank to flush the additional solids into the recovery tank sump. This allows additional solids to be pumped out, eliminating the need for manually troweling out the overwhelming solids load. Maintenance for the vacuum fan drive and the high pressure water system are easily accessed on the left side of the rear module. The final water filter tilts out to the rear for easy service. The entire rear module tilts back for access for chassis maintenance. An optional magnet on the front of the cleaning platform collects nails, screws, and other iron-based hazards for the benefit of routine traffic flow. The air-conditioned 61 horsepower Toolcat carrier includes all-wheel steer for excellent maneuverability in urban areas, traffic, and tight spots. Traverse does not alter the base vehicle or its systems. We tap into the high-flow hydraulic system to drive our cleaning module and pull 12 volts from the Toolcat battery to power the dedicated Traverse controls. The cleaning platform connects to the carrier through a standard bob catch hitch. It can be detached within minutes to allow seasonal or temporary use of any of the 40+ attachments available for the Toolcat carrier. Contact Traverse for a free Pervious maintenance guide, free consultation about your specific conditions, contract services, and pricing and availability of options and equipment. Okay, so Pervious maintenance, pavement maintenance guide. Maintenance. We published this last summer, and the idea, back again to what we've heard before, is how do you maintain this stuff at a reasonable cost? And what you saw there, we're applying a lot of energy. It's a time over target. You've got a certain amount of energy you got to get into the ground. That's not a cheap procedure. Let me see here. Okay, there we go. So this is from our Pervious maintenance manual. Inspection. And we've talked about this several times all day. You got to go out and you got to take a look. Anytime you see debris on your pervious surface or on the surface next to it that's going to run onto your pervious surface, there's going to be a certain amount of that's going to be crushed and it's going to end up in your pervious material. So you got to keep it clean. And obviously everyone does that with their street sweeping, but you get into parking lots. What we see a lot when we go into parking lots is corners and areas that haven't been swept. And there's lots of leaves, pine needles, and things like that. Anything in there, that is subject to crushing, you should keep it clean. And you can do that very cheaply. You can do it with a leaf blower. You can do it with a front mounted broom on this Toolcat carrier that you just saw. But some way you want to keep that material off. You want to go out and you're going to watch. And we talked about that before. Everybody's out looking at it. I think it was Mr. Seagal that said, yeah, we do an infiltration test, but you can look for puddling. You can turn a hose on it. You can dump a water bottle on it. You can go out with your umbrella to make sure that how your pervious is behaving. The key is, in my mind, is the regular maintenance. You sweep it and you take care of that extra material that's showing up into your pervious by seasonal pressure washing. So first thing you do is you go out with your leaf blower and you keep it as clean as possible. And the sooner you can get them off, the better. And do it on a schedule. I think I hear it all the time. I think everybody's on a street cleaning schedule. The way to keep your pervious functioning and keep away from that overwhelming load that came out of that street you just saw in that demo, which means that pervious was not functioning. that water was going right, sheeting right off of that and into the storm sewer, just like it was in Queens, New York. You need to go out and you got to pressure wash it. One way or another, you got to pressure wash it to get down through into those voids, not only to take the material off the top, but to also get into those voids and get that stuff removed seasonally. And then the big bio loads are in the spring and the fall. My recommendation is right after that happens, you go out with your sweepers, you get all the loose stuff off and you go through and you do maintenance. It's quicker, it's one pass, and you're done for the 6 months. And in the same in the fall. You'll also notice, and you can tune that up a little bit because depending on the forestation around your plot. If you're out in the middle of a parking lot with no trees around, that's one thing. But when if your parking lot is surrounded by trees in the beautiful area you live in, you're going to have more loading. You're going to have more material going into your pervious. So this comes right off of one particular page in our maintenance manual, maintenance guide. You're welcome to a copy. If you want one physical, we'll send it to you. Send me an email or something, but you can download it right off our website. Videos are there. The study from University of New Hampshire is there, some other things. So that's about it.